which element is in the D block of the periodic table. So all you do is look at the periodic table, S, D, P, and F. Look at the D block, and you can see it's tantalum. Which species contains an element with oxidation state of +4? NO2 plus. So the overall charge is +1. So -4. So that means it's +3. So it can't be that. -6 +5. Chlorine. This one, it might be this one. We've got hydrogen, H2, so 2 plus. Oxygen, well, it's 3 of them, so -6, -2 times 3, -6. -6 plus 2 is -4. Therefore, it will have an oxidation state of +4, so the answer is C. And if you look at PCl5, well, Cl is in group 7, so -1, times by 5, we have -5, and then to get an overall charge of 0, we're going to have to add 5. So it's going to have a +5 oxidation state, same as B, phosphorus. So the answer is C, the +4 oxidation state. What is the density of gold in kilograms Dm-cubed? This one is a bit of a tricky question, because it doesn't give you the MR, so a lot of students, including myself, don't think about moles and mass and how to do it. But obviously density is mass over volume. But in this case, we want mass in kilograms and we want volume in dm cubed. So we can find out the mass because we know moles is mass over mR over mR, therefore mass is moles times by mR. We have got the moles and we know it's pure gold, so all we do is look at gold, and probably going to be a bit harder to find gold, but we should find it. There we go, AU. The MR of that, 197.0. So the mass of gold is going to be 197.0 times by the number of moles, 392. Divided by the volume, 10 times 10 times 40. 10 times by 40. However, because we want it in dm cubed, we have to divide it by 1000, so times 10 to the power -3. And because the mass originally in grams that we want in kilograms, we also have to divide by 1000. So if we do that, 197. I'll put brackets around it, 7.0 times by 392. 197.0 times by 392 times by 10 to the power -3 divided by 10 times 10 times 40 times 10 to the power -3 should get 19.306. So the answer is B, 19.3. So question 13. Ions of two isotopes of iron are shown. Which statement is correct? The ions of both isotopes have this electron configuration. Let's skip that one for now. Let's look at if we can cancel any ones, because we know they're just incorrect. The ions of both isotopes contain 26 neutrons. Isotopes of atoms of the same element with the same number of protons but different number of neutrons. So just by the definition, B has to be incorrect. After acceleration, F53 Fe2 plus has fewer protons than F56 Fe2 plus. Isotopes are atoms of the same element with the same number of protons but different number of neutrons. Can't be C. And you can see how I've eliminated 2, so now I'm left with a 50% chance of getting either A or D correct. So which one is it? Well, if we look at D, after acceleration to the same kinetic energy, 56 Fe2 plus will move more slowly than 53 Fe2 plus. That is correct. Reason being is because 56 Fe2 plus is a heavy ion. They both have the same charges, but 56 2 plus is more. It's got more number of neutrons. Yeah, so it's gonna be a heavy ion, therefore it's gonna move slower. So that is absolutely correct. And you can see how I didn't even need to calculate the electronic configuration of these for A. I realize B and C are wrong and D is correct. 14. What element is X? Well, if we look at this graph, look at the successive ionization energies, we can see where's a massive jump in ionization energy. 1, 2, 3. It's here. When the electron is being removed from the third outer shell. So what does that tell me? Is that our answer has to be in group 3. That's what it tells me, that's for sure. So because there, that's when the electron being, it has to be in, element has to be in group 3. Now if we look at it, we've got aluminium and boron in group 3. So it can't be A and it can't be B, so we're either left with aluminium and boron. However, if we look at how many electrons boron only has 5 electrons, whereas for this graph, it goes up to 8. And the electrons being moved from the 8th out electron shell, whereas aluminium has 13, so it will keep going. So the answer is C, because boron only has 5 electrons, so it cannot be boron. 15. Which of these decreases down group 2? First, ionization energy. Just testing your trends. This is just the trends AO1 question. 16. In the balanced equation, the mole ratio for sulfuric acid to water is, which one is it? So how do we do this? Well, we've got 2. So if we look at each individual element, we've got K2, Cr2, Cr2, O7, but then we've also got 7 oxygens, 12 oxygens, that's 19, plus another 4, that's 13. However, on the right hand side, we have, well, let's just do the hydrogens. We have 6 hydrogens, 7, 8. Okay, yeah, I feel like this is how I'm going to solve it. So I'm just going to write down every one. Kr, Cr, oxygen, hydrogen, and copper. Kr, Cr, oxygen, hydrogen, copper, and sulfur. I'm just going to tick if they're already balanced. That is Cr is, yep. Oxygen, well that's, we've got 7 plus 12, 19. Plus 4, 23 oxygens on the left hand side, and we've got 12 plus 1, 13, 13 plus 12, 25, 25 plus 4, 29 oxygens. So these oxygens aren't balanced, and we look at the hydrogens, we've got 6, 7, 8. So yeah, we've got 8 hydrogens on the left hand side, and we've got 2 hydrogens on the right hand side. So the hydrogen is not balanced. And if you look at, what was that final one? Copper. 6 coppers on the left hand side. 6. It's not copper, carbon. 6 carbons on the left hand side. 6 carbons on the right hand side. Yep, so that's 100% balanced. And also I'll tick it. And sulfur. 1 sulfur on the left hand side. 1 sulfur on the right hand side. So that is balance as well. So now we just need to look at how do we make these the same. Well, if I put for the hydrogens, well, we need 6 more oxygens on the left hand side, 29 to 29, but I also need 6 more hydrogens on the right hand side. So if I put a 6 on the It's getting confusing now. If I put a 7 on the right hand side, I'll have 14 hydrogens, and I'll have 36 oxygens. And if I put a 6 on the left hand side, I'll have 12. I'll have 14 hydrogens, and I'll have 24 extra. No, I don't want that, do I? If I put a 4 on the 4, so I feel like this one's definitely gonna be 7 to get. Yeah, if I put 7 here, then there's 4 here. Yeah, okay. C. It's clearly not going to be A or B looking at it. So we're left with C or D. And if you just put them into the equation, I should have just done that. Once I've realized that, and then just substitute in the equation, then we could have found it out. What is the reducing agent in this reaction? H plus? No, definitely not. It's going to be B. C2O42 minus. Question 18. Which substance exists as a macromolecule? Definitely not A. Definitely not C, phosphorus. That's got a weak van der Waals force between molecules. So we're left with silicon dioxide and magnesium oxide, and it is also not magnesium oxide. The answer is silicon dioxide, SiO2. Question 19. Pale brown mixture of NO2 and N2O4 is to reach equilibrium in sealed gas syringe according to the following equation. When the plunge is pushed further into the syringe, pressure increases and the mixture becomes pale in color. Okay, this one's really tricky. But what it tells me is that when the plunger is, so it tells me when the plunger is pushed further into the syringe, the pressure increases and the mixture becomes paler in color. Well, if the pressure increases, equilibrium is going to shift to the side with fewer moles of gas to oppose the increase in pressure. So it's going to shift to the right hand side. There's only 1 mole of gas here, and the mixture becomes paler in color. That tells me this is the pale one. Okay, because it becomes more pale in color. When the syringe is placed in a hot oven, the mixture becomes darker in color. Well, that tells me that the forward reaction, because if the syringe placed in a hot oven, so temperature increases and the mixture becomes darker in color, therefore it shifts to the left hand side, that tells me that the left hand side, because if you increase the temperature at equilibrium, it's going to oppose to shift it, so it's going to go to the endothermic direction. That tells me the forward direction is exothermic, it's negative. Okay, so it tells me the forward reaction is exothermic. So it can't be B or C. Forward reaction is exothermic and NO2. Well, if this is brown, and when you increase temperature becomes dark in color, that tells me NO2 is brown. Because we only got pale and brown, so therefore NO2 is brown. NO2 is brown, and the forward reaction is exothermic. Which molecule has the largest dipole? Okay. Well, definitely not D. Symmetrical molecule dipoles cancel out. Same with C and BF3. Well, BF3 is just like they're all pulling equally. Because remember, boron is in group 3 attached to 3 fluorine, so it's going to have Nolan pair of electron values. With chlorine has got 7 outer electrons, so it bonds to 3 Fs, and it still has 2 lone pairs of electrons, so that is going to be the one with the largest dipole. 21. In a molecule of a hydrocarbon, the fraction by mass of carbon is 9/11. What is the empirical formula of the hydrocarbon? So it tells me the fraction by mass of carbon is 9/11. What's the empirical formula of the hydrocarbon? Let's find out the fraction by mass of each of these. Well, fraction by mass of carbon in this case is going to be 12/13. Fraction by mass of carbon in this case, 12/15. Fraction by mass of carbon in C, 12 times by 3, 36. 12 times by 3, 36. 36 plus 8, 44. It's going to be 36/44. In this case, 12 times by 5 is 60/60 plus 12, 72. So it's definitely not A. It is not B. So it's either C or D. And we look at C, 36/44. 36/44. If we divide it by 4, we'll get 9/11. So, no, we won't get 9/11, but you know what I mean. It can be simplified to 9/11. 36 divided by 4 give you 9. 44 divided by 4 would give you 11. So the answer is C. C3H8. Question 22. What is the final volume of gas after the reaction is complete? Well, it tells me 30 centimeters cubed of xenon are mixed with 20 centimeters cubed of fluorine. And first thing I would look at molar ratio. They're all 1:1:1 molar ratio. What is the final volume of gas after the reaction is complete? It's not going to be as simple as you expect. Well, what this tells me is that Xe is in excess, because if it's a 1:1 molar ratio, Xe should be 20. It's in excess. So that tells me there's 10 remaining. 10 centimeters cubed of gas remaining, and obviously a 1:1 molar ratio, so we've got 10 here, right? But again, we've got 1:1 molar ratio, and this F2 fluorine is still 20. So now we add those together, 20 plus 10, that will give me 30 centimeters cubed. Just the idea, that's in excess. 30 minus 20 will give us 10, and obviously the fluorine is still formed, so 20 plus 10 gives us 30. Which of the following solutions would react exactly with a solution containing this much of sulfuric acid? Moles, concentration, and volume. Just find out the moles of each one. 0.05. Um, 100 divided by 1000 times by 2.00, 0.2. 100 divided by 1000 and by 2.00, 0.2. 50 divided by 1000 times by 1.00, 0.05. And now if we look at it, well, obviously it's not going to be B or C, but I've got A and B, A and D both have the same amount of moles, 0.05. They've got same concentration, same volume. However, this is with the H sulfuric acid, and sulfuric acid is H2SO4. So we've got 2 H plus ions. Well, if we look at potassium hydroxide, we've only got 1 H plus ion. And if we look at D, barium hydroxide, we've got 2 H plus ions. Therefore, the answer is going to be D. So that is very tricky as well. And 24 tells me if 2 moles of sodium azide, NaN3, reacts in this way, how many molecules will be formed? So we know 2 moles of sodium azide forms 2 moles of sodium and 3 moles of N2. We also know 10 moles of sodium forms 1 mole of N2. So if we want to find the number of molecules of N2 formed, if 2 moles react in this way, how many molecules will be formed? Well, we're going to divide by 5. I'm going to do 1 divided by 5 for molar ratio. So that will give me 0.2 moles. 0.2 moles. So 2 Na gives me 0.2 moles of N2. But how many molecules of this will be formed overall? Well, we've got 3 moles and we've got 0.2. So it's going to be 3 plus 0.2, which is 3.2 moles. But we want the molecules, so we need to times it. 3.2 times by Avogadro's constant. And if we do that, I should get 1.93 times by 10 to the power 24. There we go. That's the end of the multiple choice questions.